The topic is understanding Kubernetes deployment strategies. We will discuss why we need Kubernetes deployment strategies, what is ruling update, what is Canary deployment strategy, what is blue-green deployment strategy. First, let's understand why do we need deployment strategies. In production, we cannot simply shut down an application to upgrade it. Doing so causes downtime, meaning users see error pages. Deployment strategies solve this by defining exactly how Kubernetes transitions our application from old version, that is version 1, to new version, that is version 2. The goal is to balance the production requirements, that is zero downtime, keeping the application available to users throughout the update. Risk management, that is to test the new version before routing all user traffic to it. Third is cost efficiency, which is to limit the amount of extra server hardware required during the transition. So simply, deployment strategy is in production environments, we cannot simply shut down the application to upgrade of that application. Meaning if your application is version 1 and you have to upgrade it to version 2 and you are thinking you would delete or shut down the application version 1 then update it to version 2. This would be a really foolish strategy because that would cause a downtime which is really costly in production environments. Meaning in companies or organizations that has applications that has real-time users in payment applications, this is a really headache. Fix that. There is a concept of deployment strategies in Kubernetes, meaning the goal is to provide zero or near zero downtime and to manage the risk and to manage the cost efficiency. Meaning if we were to not implement deployment strategy and we would shut down the application and then deploy the version 2 manually, that would at least cause 15 to 20 minutes of the downtime, which you might think is okay because if your application doesn't have traffic then it is okay. But in production environments, when there is a lot of traffic for applications or websites, this is a costly strategy. Meaning if there is Amazon, Instagram or other platforms that had 10 to 20 minutes of downtime, that would really be costly to the organization of the company. To fix this, there is a concept of deployment strategies. By default, there is rolling update strategy and there exists Canary update and there exists blue-green. By implementing those strategies, we ensure that there exists zero or near zero downtime, meaning that keeps the application available to users throughout the update, meaning provides risk management, which is to test the new version before routing all users' traffic to it. So we can test the new version by providing a bit of traffic, not 100% to the new version, so we can have the feedback of those new versions. And third is cost efficiency. We limit the amount of extra server hardware required during the transition. Now first is rolling update. This is a default strategy in Kubernetes. It replaces the old version of our application with the new version gradually, one container pod at a time. How it works? Kubernetes spins up one pod of version 2. Once it is healthy and ready to accept traffic, Kubernetes terminates one pod of version 1. This repeats until all pods are running on version 2. So rolling update is a default strategy in Kubernetes. It is to replace the old version of the application with the new version gradually, one container, that is pod at a time. This works by Kubernetes spinning up single pod of version 2. Once that version 2 pod is healthy and ready to accept traffic, Kubernetes then terminates single pod of version 1 and replaces it with the version 2. This repeats until all the pods of version 1 are replaced with the healthy pods of version 2. What are the pros of this rolling update strategy? Zero downtime, meaning it is very cost effective as it only requires a tiny amount of hardware resources during the update process that is controlled by the parameters like max search. Cons or the disadvantages of this strategy. For a brief period, both version 1 and version 2 are running simultaneously. If our database schema changed significantly between versions, this can cause data mismatch issues. If a bug exists in version 2, a portion of our users will experience it immediately until the update is manually rolled back. So there are pros and cons of every strategy. In rolling update, the pros are like it is zero downtime or near zero downtime, and it is very cost effective as it doesn't require much of a hardware resource, as it requires only tiny amount of extra hardware resource during the update process, which is controlled by parameters like maximum search that is controlled by us. And cons or disadvantages are, so So for a brief period, both version 1 and version 2 are running simultaneously, meaning if there is the update with respect to rolling update happening, meaning version 1 pods are replaced by version 2 one by one, and it can be a slow or fast process depending on how many pods are running. So if that database schema is changed significantly between these versions, that can cause data mismatch issues. And also, if a bug exists in version 2, a portion of our users will experience it immediately until the update is manually rolled back. So rolling update strategy is when we already know that the application is 100% healthy and 100% production ready. If we thought that the application is 100% production ready but it was not, so that would mean that the version 2 is exposed directly to the users, and that users can experience that bug or that error. Rolling update strategy is to replace the existing version with the version 2. It is not like we are testing version 2 with respect to version 1. No, we are directly aiming to deploy version 2 by replacing it with version 1 one single pod at a time. So if our application had bugs in the version 2 and we did debug it before the production, that means a portion of our users will experience it immediately until the update is manually rolled back. That was about rolling update strategy. Now let's discuss what is Canary deployment strategy in Kubernetes. It is named after the historic canary in a coal mine practice. This strategy exposes the new version to a tiny fraction of real users before deploying it to everyone. How it works: we deploy version 2 alongside version 1, but we configure our router or ingress controller to send only 90% of traffic to version 1 and 10% to the version 2. DevOps teams monitor performance logs and error rates on the 10% pool. If everything looks stable, the traffic weight is steadily increased to 100%. So Canary deployment strategy is where we deploy version 2 alongside version 1, but version 1 will have 90% of the traffic and version 2 will have 10% of the traffic. We configure that using router or ingress controller. So DevOps team will monitor performance logs and error rates on that 10% of version 2 traffic pool. And if everything looks stable, the traffic weight is steadily or gradually increased to 100%, meaning if the application looks stable on the version 2, then it can be extended to 20% and 80% would be on version 1, and if it is more stable, then it is gradually increased to 30% on version 2 and 70% on version 1. It is done until there exists 0% on version 1 and 100% on version 2. Now, what are the pros and cons of Canary deployment strategy? First pro is maximum safety. If a catastrophic bug exists in version 2, it only impacts a tiny fraction of our user base. Canary deployment strategy is ideal for running real-world performance tests under actual user load. Cons are managing traffic splitting requires extra infrastructure tools like a service mesh or advanced ingress controller like Nginx or traffic, and slow rolling process as we must wait and monitor metrics at each incremental traffic stage. Canary deployment strategy is one of the most reliable strategy in production, meaning if a catastrophic bug exists in version 2, it only impacts a tiny fraction, that is 10% for example of our user base initially. So we can fix it ASAP, and it is ideal for running real world performance tests under actual user load. So that 10% which we are deploying on the version 2 is of actual real world users. So it tests under actual user load, that is real world performance. Cons will be managing traffic splitting requires extra tools, that is in an infrastructure, for example service mesh or advanced ingress controller like Nginx or traffic, meaning we require a bit of hard work to make this happen. And it is also a slow rollout process as we must wait and monitor metrics at each incremental traffic stage, meaning it is a slow process as we wait and monitor metrics of each incremental traffic stage. If it is 10% and 90%, we monitor and wait to see how it works, and if it is 20 to 80, and we also do the same. We watch, wait and monitor until it is 100% on the version 2 and 0% on the version 1. That was about Canary deployment strategy. Now blue-green deployment strategy in Kubernetes. This strategy cuts risk completely by running two identical isolated environments at the same time, then switching traffic instantly. How it works: blue is our active production environment running version 1. Green is an exact clone environment where we deploy version 2. While green is completely hidden from the public, our QA team or quality assurance team fully test it. Once verified, we change the configuration of our load balancer or Kubernetes service to instantly point all traffic away from blue over to the green. So blue-green deployment strategy cuts the risk completely by running two identical isolated environments at the same time, then switching the traffic instantly. Meaning blue is our active production environment of version 1, that is like the old or current version, and green will be the version 2 or the targeted version. In this strategy of blue-green, users will only experience a single version at a time. Meaning if a single user is experiencing version 1, all users will experience version 1. And if a single user is experiencing version 2, all users will experience version 2. This is not like other deployment strategies where gradually we increase the traffic from version 1 to version 2, and some users are experiencing version 1 and some users are experiencing version 2. No, in this strategy, either users will experience version 1 or either users will experience version 2, which means there will exist two environments, meaning two resources that has the same production environment as version 1. Blue will have active production environment of version 1 and green will have exact clone production environment of version 1, that is called version 2, which is an updated version of it. While green will be completely hidden from the public, the QA team fully tests that application. Once it is verified, the configuration of load balancer or Kubernetes service is changed and it is instantly pointed towards all traffic away from blue over to the green, and it can change from green to blue while changing these configuration files. So that would mean there must exist two environments, that is version 1 and version 2. Even if version 1 is in use, this version 2 environment must also be active to switch it instantly, meaning it is a costly deployment strategy. So now let's understand pros and cons of blue-green deployment strategy in Kubernetes. First pro of this strategy is instantaneous switchover, means zero downtime. The switch between blue-green is instant as we already have both of the environments already running with the resources it takes. So it is an instant switch over between blue and green to blue, which means zero or almost zero downtime. Second pro is instant rollback. If something breaks immediately after the switch, we simply change the router pointing back to the blue. So as I mentioned, if something breaks in the version 2 or the green, we can instantly change the configuration files and switch to the version 1 or the blue, as both of these will have their environments already running even if it is not in use. Third pro is no version mixing. Users interact exclusively with either version 1 or version 2, never both at once. As I mentioned, there is no users that will experience version mixing, meaning if a single user within blue-green deployment strategy experiences version 1, all users will be experiencing or using version 1, and if it is version 2, all will experience version 2. It is never both at the same time, which is in the other strategies, that is Canary and rolling update, where we gradually increase the traffic and we gradually deploy the pods one pod at a time. There was strong possibility and chances of both traffics existing in version 1 and version 2. Now cons of blue-green deployment strategy in Kubernetes. This is extremely expensive because we must run two full copies of our production infrastructure simultaneously. Our hardware resource utilization doubles during deployments. As mentioned, this is really expensive strategy because we are running two full copies of our production infrastructure simultaneously. That is, version 1 is our production infrastructure that is running and version 2 production infrastructure that is running. Even if we are not using version 2 or version 1, that would still mean a single version is idle and still running. So that was about the deployment strategies. Now let's compare it in this table. Metric, that is downtime. In rolling update, this is none. In Canary, this is none. In blue-green, it is also done. None means is zero downtime or it can be near zero downtime. extra infrastructure cost. In rolling update it is low, whereas in Canary it is low to medium. In blue green it is high, 100% extra infrastructure cost, because there is these two identical production environments. Metric rollback speed. In rolling update it is low, it recreates old pods with the new version ones. In Canary it is fast, shift traffic back. In blue green it is instant, change router target. Metric, that is user exposure risk. In rolling update it is medium. In Canary it is low, isolated blast radius. In blue green it is medium to high. Metric, that is implementation complexity. In rolling update it is native or built-in. In Canary deployment strategy it is complex, that is it requires traffic control, that is ingress controller and all this. And in blue green it is medium, it requires environment configuration cloning. So that is it for the video today. Thanks so much for watching. Do let me know in the comments if you have any questions. Thanks, have a great day. Bye.